A pleasant greetings to all. In this video, I am going to explain a problem on power transistor. The power transistor has a switching waveform as shown in figure. If the average power loss in the transistor is limited to 300 watt, find the switching frequency at which transistor can be operated. Here switching waveform is given, the maximum current as well as voltage value also given. First, we are going to find out energy loss during turn on. So, what is the formula for energy? Energy is power into time. See here, E on is 0 to T on. This is the limit. IC into VCE into dt. IC into VCE into dt. So, first we are going to find out the equation of IC. So this is the increasing waveform. I see the waveform is increasing waveform. So how to write this? Y is equal to mx. What is y? Y is IC. M is the slope. Slope is y by x. Y is ICS. X is 50 microseconds. So 50 into 10 power minus 6 into, so what is the value? Mx t. Instead of x, we are having t. So this is the equation. And next, in the similar manner, write voltage equation. So voltage is the decreasing waveform, decreasing slope. So decreasing slope is, the slope is minus. So VCE equal to minus VCC divided by, what is the time? Time is 40 into 10 power minus 6 into t. But you have to subtract the total from VCC. So what is the equation? VCC minus VCC by 40 into 10 power minus 6 into t into dt. So E on equal to, substitute the values for ICS and VCC. ICS is 100, VCC equal to 200. Now I have to reduce this 50, 100 that is 2, 200 by 40 that is 5. Now 2 into 10 power 6 into t into 200 minus 5 into 10 power 6 into t into dt. Multiply this 400 into 10 power 6 into t minus 10 into 2 into 5, that is 10 into 10 power 12 into t square into dt. So what is t on given? T on given is 40 microseconds. So t on is 40 into 10 power minus 6 seconds. Then take integration and apply the limits. So 400 into 10 power 6. What is the integration of t? That is t square by 2. But the time given is t on. So t on square divided by 2 minus 10 into 10 power 12. So what is the integration of t square? T cube divided by 3. T on cube divided by 3. The time limit given is 0 to 40 into 10 power minus 6. Now you have to substitute this value instead of T on and we'll get the answer 0.32. And next the same we get the answer 0.2133. So net value is 0.1067 watt second. Next, energy loss during turn off. Here also we are going to use the similar equation. Already we have used in the E on. So E off is 0 to T off. IC into VC into dt. So E off is 0 to T off. Now this is a turn on period. So turn on, the current waveform is a decreasing slope. Voltage waveform has increase in slope. So ICS minus ICS divided by 60 into 10 power minus 6 into T into VCC by 75. This is for VCC divided by 75 into 10 power minus 6 into T into dt. Now E off is 0 to T off 100 minus 100. Substitute the values here 100 and 200. So what is E on now? 0 to T off into 100 minus 1.667 into 10 power 6 into T into 2.667 into 10 power 6 into T into dt. So what is E on? E on is 0 to T off 267 into 10 power 6 into T minus 4 into 445 into 10 power 12 into T square. What is T off now? T off given is 60 microseconds. So then you have to apply the integration. So E off is 267 10 power 6. Here take the integration. So t square by 2. T half square divided by 2. Here t half cube divided by 3. So limits are 0 to 60 into 10 power minus 6. Now we have to substitute the value for t of. We get the answer 0.4806, and what is the value for the next term? 0.3200. So what's the net value? 0.1605 watt second. Now we are going to find out total energy loss in one cycle. So one cycle means turn off and turn on. So turn on 0.1067 and turn on, that is turn off 1605. So net is 0.267 watt second. Average power loss in a transistor. So energy equal to power into time. So power is equal to what? Energy divided by time. So what is energy here? The energy in the time. So energy in the, what is time? Time is 1 by F. So E in the F. E 1 by T is F now, E in the F. So P is equal to E in the F. Energy in the frequency. Switching frequency, energy loss in one cycle is average power loss. So F is equal to what? F is equal to power divided by the energy. So what is the power given? 300. What is the energy loss? 0.267. Now we'll get the answer 1123.6 Hertz. Thank you. Have a nice day.